Alright, welcome back to another math tutorial. Today we're going to be quickly discussing combining like terms. So first, what do I mean by like terms? So a like term is when the variables and the exponents are the same. For instance, if I say something like 2x plus 3x, the variables, our single x, are the same. The same with if I mentioned, or if I said something like 3y squared plus 3y squared. The y squareds are the same, so you can combine those like terms. I do like to think about this in terms of what you would learn in grade school, or the old phrase apples and oranges. You want to combine the same thing. So I have a quick little example here. So if I have 1, 2, 3 tigers, and I add 2 tigers plus 2 little bears, if I ask you how many tigers there are, you would say there's 1, 2, 3, 4, 5 tigers. There's 7 animals total, but I just want to know how many tigers. So tigers are your like term. If I ask you how many bears there were, there'd be 2. You cannot combine these two to say 7 tigers. There's only 5 of those. So we have our visual representation. Now let's do a couple example problems. I'm going to do one that's straight from a quiz, and then I will just make up one to emphasize the difference or the importance of combining terms with the same exponent. Alright, here is one example problem we can go ahead and look at. This is straight from one of the quizzes. It says which expression is equivalent to 9p minus 3p plus 2. So we're looking for the equivalent expression from the term given. So if we look at terms that are alike, you notice we have a 9p and we're subtracting 3p. The sign in front of each term is extremely important because you're going to treat those as just like you're adding or subtracting. So if I have 9p minus 3p plus 2, I always say that numbers go with numbers. I don't have any other numbers that go along with this, so the only thing we have that can be combined are the 9p and 3p. So all you have to do is take 9p, subtract 3p, and hopefully you can do that, and we get 6p. And since 2 can't be combined with anything else, it just stays the same. Alright, let's look at another example problem. This one's a little more difficult. Remember I told you about like terms have to have the same exponent, and the terms have to be the same. So let's look at a problem like this. We have 2x squared plus 4x plus 3y plus 6x squared minus x squared. So the first thing we need to do is we need to identify which like terms we can combine. So I have a 2x squared here, so I'm looking for any other term that has x squared in it. It only can have an x squared. So if I go to the first one, which is 4x, that's just a single x, that's not an x squared, that's a no. Plus 3y, a y is obviously not an x or an x squared, so he's a no. I have a 6x squared y, this one's close. It has an x squared, but it has this added component of a y into it. That does not make these two terms the same. And then finally I have a subtract x squared here. X squared here, x squared here, so that means we can combine like terms. So in big problems like this, I usually like to circle the common terms. If I have a marker or a colored pen, I like to do these in different colors, or sometimes I box some, underline some, square some, something like that. So the only two terms we can combine in this is the 2x squared minus x squared. So I'm taking 2 of those, and I'm subtracting 1 of those. That leaves me with just a single x squared. And then the rest I would just have to recopy, since I cannot combine them with any other term. Alright, hopefully this quick lesson on combined terms helps. If you have any more questions or concerns, you know where to get a hold of me. Have a good day.